on proportional and non-proportional relationships. The great news is there is nothing new in this section. It's almost all stuff that you've already talked about very recently, and we'll be able to compare it to things we already know. So for a warm-up, we're going to write an equation for an arithmetic sequence for the nth term. Go ahead and pause your video and try this, and then I will give you the answer. So whenever you have an arithmetic sequence, the first thing you need to do is find the common difference. Here the common difference is subtracting 4 every time. And once you know the common difference, we just use our formula that a sub n equals a sub 1 plus the quantity of n minus 1 times d. And then we just plug in these quantities. A sub n equals a sub 1, which is our first term, negative 11 plus the quantity of n minus 1 times negative 4. Hopefully a pretty easy review for you. So now, proportional relationships. This all sounds really complicated, but notice, they are in the form y equals kx, and they will pass through 0, 0. Now, where have we heard that before? Oh yeah, it's just direct variation. So what are proportional relationships? They are just an example of direct variation. So there is absolutely nothing new on this page because you know what direct variation is. It's in the form y equals kx, k can equal 0, and the graph passes through 0, 0. Proportional relationships are direct variation. They are one and the same. So Marcus is a personal trainer at a gym. In addition to his salary, he receives a bonus for each client he sees. So here we've got this information. So let's graph the data. So here it's already graphed for us. What can we deduce? And by deduce, that basically means figure out. What can we deduce or figure out from the pattern about the relationship between the number of clients and bonus pay? Well, hopefully you can see that as clients increase, if I increase the number of clients, then I'm also going to increase his bonus pay. That's our relationship. Now, I want to look for a pattern that can be described as an equation. Notice, my rate of change is 45 over 1. Every time it goes up 45 for every one customer. So now, to get my equation, this is just like direct variation, but now it's even easier because I've just found my rate of change because I did the change in y over the change in x. But I also know that's the same thing as slope, because we know rate of change and slope are the same thing. But then I remember that slope is always the number in front of x. So now I've just got my equation, y equals 45x. Notice all these things we've been talking about this chapter are all coming together right here. Finding the rate of change, remembering that rate of change is the same thing as slope, and then remembering slope for direct variation is the number in front of x, and that's what a proportional relationship is. So it may seem kind of complicated when you first look at it, but once we realize this is all just what we've already talked about, these problems should be really easy. Now that we've got our equation, we can see if he sees 8 clients, y equals 45 times 8, just plug in 8 for x. And when I do that, I see he should make $360 when he sees 8 clients as his bonus. So hopefully this is encouraging to you because you've looked at this and realized you already know exactly what's going on because you've done all of this before. It's just a different name.